In every single one of our homes, there's this invisible engine. It's running all the time, right in the background. It's that silent system we completely ignore when it's working and, curse when it's not. Our HVAC system. It's probably the single biggest factor in how comfortable we feel every day.
So just think about it for a second. What does it really take to keep your space feeling just right? Not too hot, not too cold, not too muggy. I mean, we just walk over to the thermostat, flick a switch, and we kind of expect magic to happen. But behind that simple little act is a seriously complex machine fighting a constant battle.
And for some homes, that battle is less of a little skirmish and way more like an all-out war. So what we're going to do is look at what happens when you put one of these systems in one of the toughest, most demanding environments you can imagine, just to see what we can learn when these things get pushed to their absolute breaking point. And our proving ground for this whole thing, Bloomington, Minnesota. This is a place that sits in a climate zone that just absolutely punishes heating and cooling equipment. Honestly, it's the perfect case study to really get a handle on the unique pressures our home comfort systems are up against. Now, what's really wild here is the sheer range we're talking about. I mean, it's a temperature swing of over 100 degrees every single year. In the winter, you've got furnaces that have to run nonstop for months just to keep the pipes from freezing over. And then, flip the calendar, and the air conditioners are working overtime against not just high heat, but this really intense humidity. But here's the thing, it's not just about the temperature. Nope. Bloomington has this kind of perfect storm of local challenges. You've got those crazy temp swings, for sure, but then you add in the heavy humidity coming off the Minnesota River Valley. You've got this high clay soil that literally moves with the seasons, and you have a mix of old and new homes with totally different building codes. It's a lot. So when you put a system in that kind of pressure cooker, it doesn't just fail randomly. It actually fails in very specific, very predictable ways. So let's take a look at the common breaking points that pop up when a system gets pushed this hard. Okay, first up is one of the most serious failures you can have, a cracked heat exchanger. Basically, this is the metal wall inside your furnace that keeps the really dangerous combustion gases, we're talking carbon monoxide, totally separate from the warm air that gets blown into your house. A crack means those gases can mix. It's a big deal. And here's the real culprit. It's that constant extreme cycle from freezing cold to scorching hot, winter after winter. It puts this incredible thermal stress on the metal. Think of it like bending a paperclip back and forth. Eventually, it's going to break. This isn't just a random part failing. It's more like a fatigue injury caused by the climate itself. All right, let's flip over to a summer problem. Have you ever been in a room where the thermostat says it's like 72 degrees, but you still feel kind of sticky and gross? Well, that's often because of an undersized air conditioner. It means the system is totally failing at one of its most important jobs, pulling moisture out of the air. And this is where the local geography just jumps right into the picture. All that humidity from the Minnesota River Valley creates a massive moisture load. A lot of AC systems are sized just to handle the temperature, but they simply can't pull that much water out of the air fast enough, so the home always feels clammy. The system's fighting a battle it was never really equipped to win. It's not just the main units that can fail. The whole delivery system can break down too. Ductwork separation is exactly what it sounds like. The channels that are supposed to carry your nice heated or cooled air literally pull apart. So you end up dumping all that conditioned air right into your basement or walls instead of your living room. Okay, now get this, because this part is just fascinating. The cause isn't a bad installation job, it's geology. The clay soil in the area actually expands when it's wet and then shrinks when it's dry. And that subtle movement is enough to shift a home's foundation over the years, physically pulling those rigid duct connections apart. Your house is literally breaking its own HVAC system from the ground up. So, we have seen how these systems can fail in some pretty spectacular ways. And when that happens, you're faced with that big, expensive question. Do I repair it or do I replace it? It can feel like a paralyzing decision, right? But there's a really simple rule of thumb that can cut right through the confusion. And it all centers on this number, $5,000. This is what's known as the $5,000 rule. And it's a fantastic, practical little calculation. Okay, let's say your furnace is 12 years old, and it needs a $500 repair. You multiply 12 by 500, and you get $6,000. Since that number is over $5,000, the rule suggests that it probably makes more financial sense to just replace it. You're likely just throwing good money after a system that's already near the end of its life anyway.
Okay, so let's say your system is down and you need to call in a pro. How do you know you're actually getting a real diagnosis and not just a sales pitch? Well, there's an ideal process, a kind of playbook that separates the real experts from the people who are just guessing.
Look, the whole process really should be this straightforward. You make the call and you get a fast response. The technician comes out, diagnoses the actual root cause, not just the symptom, and then gives you a written estimate before they start any work. Then, only after you give the okay, they do the repair and test the system to prove that it's actually fixed. Simple, transparent, and totally professional.
And this right here, this is your checklist for quality. A true pro uses diagnostic tools, not just guesswork. They should be able to show you photo evidence of the broken part, explain not just what broke, but why it broke, and, this is key, give you that written estimate before they even touch a tool. This is all about getting the facts, not feeling pressured.
All right, let's zoom out and land the plane here. What's the real lesson for all of us, whether we live in Minnesota or sunny California? It really comes down to understanding the specific story of your own home. So here's the bottom line. The extreme example of Bloomington really just teaches us that every single home's HVAC system is being shaped by its own unique environment. Your local humidity, the kind of soil your house is built on, your home's age, the quality of your insulation, all these little factors are writing a story that determines how your system performs and, eventually, when it's going to fail.
And that brings us right to the final question. That invisible engine in your house is constantly reacting to its surroundings, day in and day out. And understanding those unique pressures is really the first step to keeping it running smoothly for a long, long time. So, what's the story it's telling you?